Hi everyone, and welcome to our video on function notation. This is something you may have seen before, you may not have seen before. So I'm going to teach it to you like you've never seen it before. So let me highlight the title here, function notation. And believe it or not, this really isn't a new lesson per se. It's just a new way of writing what you've already been working with. So let's go through these examples, and hopefully by the end of this, we have total sense of this lesson. So what it says here is, so far in Algebra 1A, we have always written equations in the form, and I'm gonna highlight over this, y equals 2x plus 4. This particular equation, as you know, is in slope-intercept form, y equals mx plus b. The main thing I want you to focus on, though, here is that it's y equals. We've always sort of written equations of lines with a y and an x. Let's move down. So what if I told you that this means the same thing right here? Now check that out. The 2x plus 4 is still the same, but it's the left side here that's no longer a y. It looks different. It's this f with a parentheses and an x inside. And the way you read that, you read this as f of x. That's a little bit different. F of x. F of x. And all that means is that you're going to evaluate your graph or your equation, or the F actually stands for function. This over here is the function. You're going to evaluate your function as you plug different x values in for x. You know, at the beginning of this chapter, we talked about how x affects y. They're in a relationship. So this is going to show me my function, my y value, when x is anything I want it to be. And that answer will come out by plugging x into the right side of the equation. Okay, so here it says the second equation, which is this one, is called function notation. And here is how it is useful. Okay, so here's how it's useful. If I want the y value when x is 5, so if I gave this equation up here to you and I said, hey, what is y when x is 5? I would have to like write that out for you. What is y when x is 5? And you would say, okay, well, let me plug 5 in. So you would say y equals 2 times 5 plus 4. And you would take that 10 plus 4. You would say y is 14 when x is 5. But do you see how I had to write out a whole sentence to ask you that? Well, when you use function notation, here's what's cool. Now if I want the y value when x is 5, all I have to ask is f of 5. See, f represents the y value or the function value when x is 5, f of 5. So then to solve that, I would just do the same thing. I would take 2 times 5 plus 4 and say that that was 14. Simple. If I want the y value when x equals 1, all I have to ask is, hey, what's the function when x is 1? What's the y value when x is 1? So that would be 2 times 1 plus 4, which is 6. The third bullet, if I want the y value when x is negative 7, all I have to ask is, hey, what's f of negative 7? So you would take 2 times negative 7 plus 4. This is going to give you negative 10. And if I want the y value when x equals a, all I have to ask is f of a equals. So f of a would be 2a plus 4. See how I just substituted the x with an a? Okay, so reading along here, the notation f of x means the function's value, that means the y, the function's value at a particular value of x. This will find the y value at any x value. Get it? I hope you do. So let's look at example 1 down here. it says given g of x. Okay, they switched the letter on me. That's the cool thing. You can do any letter you want. G of x, f of x, h of x, s of x. You can do anything you want. So given g of x equals negative 3x plus 1, we're to find the following. Okay, so they want g of negative 1. The function when x is negative 1. That's the y value when x is negative 1. So I'm just going to take negative 1. I'm going to fill it in for this x. So negative 3 times negative 1 plus 1 is going to be positive 3 plus 1, which is 4. And g of 0, that means what's the y value when x is 0? So I'm going to plug that in for x. Negative 3 times 0 plus 1 is 1. And g of 1 is, hold on, my phone is ringing. I'm going to silence that. Sorry about that. G of 1 would be negative 3 times 1 plus 1, which is negative 2. And g of 2 would be negative 3 times 2 plus 1, which will be negative 5. So it's pretty simple to work with f of x or g of x or anything of x notation. Okay, let's flip it. Go to another, oh, there's more to this one. It says, now graph the function g of x by plotting the points I found. Okay, so let me go back here. Sorry about that. Let me grab my points. So I have to plot. This first one would be when x was negative 1, g of x was 4. So that means negative 1, 4. My next point, 0, 1. 1, negative 2. And then 2, negative 5. So let me jot those down. So it's negative 1, 4, 0, 1, 1, negative 2, and 2, negative 5. Okay, now I got my points. So if I plot these, so negative 1, 1, 2, 3, 4 would be about right there. 0, 1, 1, negative 2, and then 2, negative 5 would be there. So you can kind of see that when I connect those dots, it makes a line. Let's not forget what g of x was. G of x was equal to negative 3x plus 1. So you can see your b there is 1, so I'm up 1 on the y-axis, and then I go down 3, right 1, down 3, right 1 to match my slope. Okay. Now we can go on to example 2. Oh, look, they changed the letter again, h of x. So given h of x equals 2 minus x, fill in the table and sketch the graph. So look at all these different x's they're giving me. So I'm going to fill these in for my x's here in the equation, and I will get out my h of x values or my y values. Okay, so let's start with negative 3. So h of negative 3, that means the y value when x is negative 3, equals 2 minus negative 3. Be careful of that double negative. And that's 5. So I'm going to put a 5 there. Okay, when x is negative 2, h of negative 2 is 2 minus negative 2, which is 4. And h of negative 1 is 2 minus negative 1, which is positive 3. And I just keep following this. H of 0 is 2 minus 0, which is 2. And h of 1 is 2 minus 1, which is 1. And now look what they did here to me. They switched it on me. They gave me h of x, and I'm supposed to find the x value. No big deal. So what you do is you put 0 where this whole h of x is. So this one would look like this. 0 equals 2 minus x. And to solve that for x, I would just subtract 2 from both sides. So I would have negative 2 equals negative x. And that's like having a negative 1x. So I'll divide by negative 1, and x will equal 2. So I'll fill that there. And then the same thing for this guy. This time h of x is -3, so I'll do -3 equals 2 minus x. I'll subtract 2. So that gives me -5 equals -x. And that's like -1x, so divide by -1 and I get +5. Okay, and it looks like they want me to plot the points here, so I'm going to plot them right off my table. So -3, 5, 1, 2, 3, 4, 5, -2, 4, -1, 3, 0, 2, 1, 1, 2, 0, and 5, 1, 2, 3, 4, 5, 1, 2, 5, -3. So you can see they line up. And more than that, if you look at the original equation, which was h of x equals 2 minus x, if you flip the right side around by the commutative property, you could write this as -x plus 2. So you can see you have a y-intercept or a b value of +2 and a slope of -1/1. So down 1, right 1, down 1, right 1. So that's how you do it. Okay, last but not least, this one says, look at the graph of f of x below and fill out these questions. So now we're going to fill out by reading a graph. So let's not forget, let's look at letter A, f of 3. This means what is the y value when x is 3? So I'm going to go to x equals 3 right here. I'm going to grab the y value, which looks to be -1. And for the next one, f of 2, what's the y value when x is 2? That's 1. That's this guy right here. And f of 1, well, let's go to x equals 1. Okay, there it looks like the y value's up at 3. And f of 0 is up here at 5. And then function at -1, x is -1, what's y? Looks like 7. And there you have it. So just to recap, to put some closure on this lesson, what I really wanted to teach you is that you can have an equation, y equals, I don't know, 1/2 x plus 7. And that's all fine and dandy. But what I want you to know is this means the exact same thing as saying f of x equals 1/2 x plus 7. These two notations are the same. They're just in different outfits. They just look different. And you will see the higher up you go in math courses, for example, I teach calculus, we almost always use function notation. This we kind of let go of after Algebra 1, it seems, and we use a lot of function notation. And that, again, is simply because it's so much easier for me to say, hey, what's f of 5? What's the y value when the x is 5? Just plug it in there. So this is sort of a higher level type notation. All right, thanks so much for watching.